All right, so welcome to our next video. We're going to take a few minutes today to learn a little bit more about the idea of equilibrium, talk about why the intersection of the supply curve and the demand curve meets the definition of what we think of as an equilibrium in economics. And then we're going to move on and talk a little bit about how to use the supply and demand model to help us understand changes, which is something called comparative static analysis. So let's start off by thinking about this idea of equilibrium a little bit more. So equilibrium. And I know that if I were to go to the dictionary, or if you were to go to the dictionary and look up the word equilibrium, and don't worry about the economic applications necessarily, but just thinking about what the term itself means, I think what you would find is terms like balance, rest, stable, things like that. And so I know my own personal first exposure to the idea of equilibrium was in a chemistry class, where maybe back in high school you go into a chemistry lab and you start off with a bunch of things that are in equilibrium. So you might go in and there might be some sort of beaker. Test my art skills here. And it's got some sort of some kind of solution in it, and that beaker has initially is in some kind of equilibrium, right? So there's this sort of red stuff down the bottom of the beaker, and then we're asked to come along and make a change, and maybe what happens is that we pour in some sort of blue liquid, and it goes into the beaker, and when that happens, the whole thing starts to smoke, and hopefully it stinks. Those are always the fun ones, and so on. That process where change is occurring is definitely not equilibrium. We might call it disequilibrium. The whole thing eventually will stop, and the compound, or whatever, the sludge, whatever it is we've created in the bottom of the beaker, reaches a new state of equilibrium. So that's kind of what we have in mind here, is thinking about markets as being either in equilibrium or disequilibrium, and then this comparative static analysis is going to show us how to compare the two situations. So let me start you off with a quick picture and talk a little bit about the idea of equilibrium first of all. So here's a market, and supply and demand sort of picture. And we know from previous discussions, you know from your reading, that this market is initially in equilibrium where the supply and demand curves intersect, right? That's the equilibrium. To understand why that point is equilibrium, we need to think about two things. We need to think about the possibility that there might be a shortage in our market, which would mean that there's not enough to go around, and the possibility that there might be a surplus in the market. And we're going to define equilibrium as the point where there's neither a shortage nor a surplus. And it turns out that that's the point indicated here, where these two lines intersect, where the quantity demanded exactly balances out the quantity supplied. But to better understand that, let me take a shot at thinking about some other possibilities. So suppose we consider this, what should we call this? Let's just call this a high price. So at this high price up here, we're going to claim, or I claim, try and explain that the market is not in equilibrium. In fact, at this high price, there's some amount supplied, some quantity supplied, which far exceeds the quantity demanded. So at this point right here, there is, in fact, a surplus. There's extra amount left over. So if you're a firm and you're selling, suppose this is the market for bread, and you're selling bread, this is a situation where you open your bakery in the morning and you sell bread all day long, and at the end of the day, you still got a lot of bread left over. And I suppose you could make croutons or something, but in general, that's not a good business model for a bakery. You want to make enough, but not too much, because it will go bad after just a short period of time. So a surplus would lead you as a baker to decide that, boy, you know, I think I need to consider lowering my price from whatever this high price is. So that can't be an equilibrium. On the other hand, if we think about a low price, this blue one right here, a low price also suffers from not being equilibrium. Here the difference is that there's some amount over here that exceeds the amount that buyers want to buy, the quantity demanded, exceeds the amount that sellers want to sell. This, of course, is the opposite case. This is a situation where there's a shortage, and if you're a bakery and you open your bakery every morning and you sell bread at this low price, you run out of bread by noon. And all afternoon people are coming in the store and they want to buy bread, and you have to say, sorry, we didn't make that much today, right? Quantity supplied was low. They say, boy, we'd really like to buy some. Their quantity demanded is high. And again, it doesn't take too much thinking to say, boy, it seems to me that we might be able to raise prices. And so what we end up with is a situation where at high prices, where high just means anything above the proposed equilibrium price, market forces are pushing down. And at low prices, market forces are pushed, that is any price below the proposed equilibrium, market forces are pushing up. Now right here, right at the point where these two things intersect, let's color that in all nice and dark. Right at that point, we can't tell either of those stories, right? Right at that intersection point, this is like a bakery that opens in the morning, they bake their bread, and all day long people come and go, and they're buying bread at this price, P star, that we're going to call equilibrium. And right as you're about to close for the day, you're just about ready to go home, all of a sudden a customer walks in and they buy the last loaf of bread off the shelf. And you think, boy, I got it just exactly right today. I set my price at just the right point, so I didn't have a surplus, I didn't have bread left over, I didn't have a shortage, I wasn't running out, and that is the equilibrium point. Again, it's a point of balance, it's a point of rest, it typically is stable, and it's not unlike the beaker situation after the process has settled down and reached a new equilibrium. All right, so we've got ourselves a clean slate here for the second part of today's lesson. So now you know a little bit more about equilibrium, why the intersection of the supply curve and the demand curve meets this definition of equilibrium. The second thing that we want to talk with you a little bit about today is the idea of comparative statics. That's a kind of a mouthful, comparative statics. But it's pretty simple to understand, really. Start with the second part, statics. Something that's static means that it's not changing. So in the context of this equilibrium-disequilibrium scenario that I described to you a moment ago with my chemistry example with the beaker and the solution and all of that, the point of equilibrium is static, right? It's a rest point. The point of disequilibrium is a point of change. It's not static. You could say it's dynamic. And so we're going to be interested in comparing equilibrium points, or comparing points that are at rest, and that's what the statics part means. And the comparative part, well, I guess I just described that, right? We're going to be doing sort of a before and after kind of scenario or comparison. So we have a comparative case, a before and after situation of equilibrium conditions. So that's what we're about. So let's switch colors here and do something kind of nice. So I want to describe. I'm going to start by showing you an example from Colander, who talks a little bit about the effects of Hurricane Irene in the summer of 2011. And at the very beginning of chapter 5, he says that in the summer of 2011, Hurricane Irene damaged farms in the northeastern U.S., destroying a significant portion of the apple crop. And as a result, apple prices rose. So what we want to know is how exactly did that happen? And the answer, which he gives, but I'll walk you through in our scenario, involves this idea of comparative statics. So we're going to start with a market that's originally in some kind of equilibrium. So let's start by get our market set up here. Right, so here's my demand curve. Here's my supply curve. And let's label the initial equilibrium point. Something like that. So the apple market, let's say, is originally in equilibrium, and apples are selling for, I don't know, $30 a box, something like that. And those $30 apples, when we're selling $30 apples, $30 a box, we're able to sell, and the market trades and exchanges 900 boxes of apples. So that's the situation before anything happens. That's the first of our two comparison points, our first to static points is this initial equilibrium point. Now, the hurricane blows in and we have a change, and the question we always need to ask ourselves with regards to comparative statics is the event that we just witnessed or that we're trying to understand a supply side event, or is it a demand side event? Right? So what we have going on today in our example is a hurricane, Hurricane Irene, and what we want to know is the effects of Hurricane Irene going to show up in the supply curve or the demand curve? And to answer that question, you really need to go back to the demand shifters and the supply shifters from our previous lesson and ask, is this one of the things that's likely to influence how buyers behave or how sellers behave? And you got to be a little careful, because we certainly expect that there will be a price effect. And when that price effect happens, that may affect suppliers and demanders. We want to know sort of the primal effect. The first thing that happens when the hurricane blows through, is it primarily an effect that impacts buyers or primarily an effect that impacts sellers? We know there could be sort of repercussions, and we'll talk about that. But I would argue that this Hurricane Irene example is a case of a supply shock. So one of the things, Colander didn't list this, but I think you could very easily claim that weather is something that should be included as a supply shifter. And so in this case, when Hurricane Irene blows in and we get a supply shock, I think we're going to get a reduction in supply. And so we're going to see the supply curve shift to the left. And what's going to happen is that we're going to expect, this sort of conforms to our intuition, we're going to expect that the number of apples available is going to fall from, I don't know, 700 or 900 to, let's say, 700, and that the price is going to go from $30 to $42 a box. So again, there is going to be an effect on buyers, but the effect in terms of our diagram shows up in terms of a change in quantity demanded as we slide along the demand curve because of the shift, oops, forgot to label my supply curve, because of the shift in supply from S down to S prime, the reduction in supply from S down to S prime. So that's an example of how comparative statics analysis can help us understand how these changes are going to impact the market. And again, the key thing is to go through and ask, is this a supply side thing? Is this a demand side thing? In some very, very rare cases, it could be both. And I'll quickly walk you through that example once I clear off my screen. All right, so just one more quick example here before we wrap up for today. I want to talk about the case where we might get an uncertain outcome when we're looking at comparative statics. That is, we might be able to say, oh yes, we know that quantity is going to increase, but price, boy, it could go either way. And the situation where this is likely to occur is when we have multiple things shocking the market at the same time. It's possible you could think of a scenario where a single event could have both supply and demand side implications. But the more likely scenario is just that we have two things going on at once, or perhaps more than two things going on at once, and that's going to cause some potential uncertainty. So let's start with, as we have all along, start with a market that's originally in equilibrium. And so we're going to indicate our initial equilibrium values. I'm going to be a little bit more generic this time. I'm just going to call that P star and call that Q star. And in fact, let's put little 1 subscripts on them so that we know that they're the first equilibrium point that we're going to consider. Now suppose that a couple different things happen in this market. Suppose that first of all there's a positive demand shock. So that's going to shift the demand curve to the right. So I'm going to draw that as a shift out here to the green one, D prime. And suppose at the same time there's a positive supply shock. But suppose that we're not sure. That supply shock could be very, very small. It could look like this one, like the blue one. Or it could be that the supply shock is really big. Maybe it's like the red one. Now, whether or not we go to the blue supply curve or the red supply curve, to S prime or S double prime, or maybe, let's draw a really super big one. Let's do gray for something different. How about one that goes way out here? S triple prime. Now, the size of the shock is not something that we're necessarily going to know, at least at this point. We may be able to add some detail later on that would allow us to check that. But for now, what we're going to do is we're going to say, okay, suppose that we have an initial equilibrium at this original intersection point. Let's kind of color that in nice like that. And then the demand curve shifts out to the right, and the supply curve is either doing a little shift, a big shift, or a really big shift. So we could be here, we could be here, and we could be there. Now in all of those scenarios, actually let me go back a second. Let's change those colors. In all of those scenarios, the new equilibrium points are these blue dots, right? So we're either at the new, that one, or that one. Now we're comparing all of those to the original equilibrium, which is the red dot. In every one of these cases, whether the supply curve is shifting a little bit, a big amount, or a huge amount, it's definitely going to result in an increase in quantity. The equilibrium quantity is definitely going to go up in this scenario. What we don't know is what's going to happen to price. So that's where the big question mark comes in this example. Are we going from the red dot to this blue dot, right? This one up here, in which case price is going to rise. Price goes up, quantity goes up. Are we going from the red dot to this blue dot? Boy, that doesn't even look like much of a change. The price is more or less unchanged. Equilibrium quantity increases a great deal. Or from this red dot all the way out to this one out here, in which case price falls and equilibrium quantity increases a huge amount from here all the way out to here. You, of course, can cook up scenarios like this where the price is the thing that we know for sure and for certain is going up or down depending on what's going on, and you have uncertainty in the quantity dimension. In this example where you're not sure how big these changes are going to be is going to be the motivation for us a bit later on to consider how we might measure the size of these changes. And so there's a little bit of a hint for future work, which is that we're going to talk about the idea of elasticity in another video or two. And when we talk about elasticity, sorry, I'm not pressing hard enough with my pen. When we talk about elasticity, that's going to allow us to quantify the sizes of some of these changes. But that's about it for now. Hope you have a great day. Thanks.